Welcome to Brain Vision.
A small bead can slide without friction on a circular hoop that is in the vertical plane and has a radius of 0.1 meters. The hoop rotates at a constant rate of 4 revolutions per second, about a vertical diameter. Okay, so here is our hoop. It has a diameter of 0.1 meters. It is rotating this way at omega. We have the bead here. This angle is beta. And this distance here is r. Okay, so find the angle beta at which the bead is in vertical equilibrium. So if it's in vertical equilibrium, it's moving in a circle, so we know that r is equal to r sine of beta, so this is our radius. And we know that the normal force is equal to the centripetal force, so that's mv squared over capital R, since that's the distance that it's rotating. So by Newton's second law, the force in the y direction is mass times the acceleration in the y direction, which is the normal force cosine of beta minus the weight, and it's equal to 0 because there's no acceleration in the y direction. So this gives us Fn is equal to mg over cosine of beta. We have the force in the x direction is the mass times the acceleration in the x direction. And we have that the normal force times sine of beta is the mass times the radial acceleration. So combining this, we get, since we have Fn and Fn, sine of beta over cosine of beta is equal to the radial acceleration over g. So the radial acceleration we'll do it up here, is equal to v squared over capital R. And they gave us a useful hint that it has the radial acceleration towards the axis. So v is equal to 2 pi r over the period. So that gives us that the radial acceleration is 4 pi squared. And then this r in the denominator will cancel one of these r's when it's squared. So r sine of beta over t squared. So plugging this into this equation gives us that cosine of beta. So sine of beta is equal to 0, or this is true. T squared g over 4 pi squared r. They gave us the period as a quarter of a second, since the rate is 4 revolutions per second. So since t is 1/4 of a second, that gives us that beta is equal to 81.1 degrees. For part B, is it possible for the bead to ride at the same elevation as the center of the hoop? So if it's the center, that means, looking at the figure, beta would be equal to 90 degrees because it would be up here. So if beta is equal to 90 degrees, cosine of beta would be 0, which means the period is equal to 0. So it has to rotate infinitely fast to have that happen. So no, it's not possible. And part C, what will happen if the hoop now rotates at 1 revolution per second? If it rotates at 1 revolution per second, that means the period is 1 second. And using this equation that we found before, that would mean cosine of beta. So if t is 1 second, cosine of beta would be greater than 1, which is not possible. So it is just going to sit at the bottom. So that's not possible. Sine of beta would have to be equal to 0, which means that it sits at the bottom.